Welcome to example number 1. The magnetic flux through a plane surface is given as 0.9 milliwebers, and in the cross-sectional area of the surface, this is a side view, is given as 3 centimeters squared, and the angle of 30 degrees is with respect to the surface. And we're asked to find out what is the magnetic field B. Some people have a hard time understanding that this is a side view of it, so I'll draw just kind of a three-dimensional view of it now. So here's a more three-dimensional view. So this angle 30 degrees is the angle that is made between the B field lines that are drawn here in blue and the surface. The normal, by the way, is this vector right here. That's perpendicular to the surface. You're told that this area is a value of 3 centimeters squared. And you're asked to determine the magnetic field B. And you're told that the magnetic flux phi sub B is equal to 0.90 milliwebers. The first thing that you should recognize, and which is a common mistake, is that the angle theta is not 30 degrees. The angle theta is the angle between the magnetic fields B and the normal or the axis to this plane. So theta in here is actually 90 minus 30 degrees, which is 60 degrees. Because B is uniform at all places along that area, we can use the magnetic flux formula. Phi sub B is equal to the magnetic field strength B times the cross-sectional area A multiplied by the cosine of the angle between the normal and the field lines B. So solving for the magnetic field, we'll have the magnetic flux divided by the area multiplied by cosine of the angle theta. The other place that people are going to make mistakes on this problem is changing it into appropriate units. So this should be changed to webers, not milliwebers. So this is going to be 0.9 times 10 to the power of negative 3 in webers. And the other problem we have is the area. The area is 3 centimeters squared, which we need to convert to meters squared. Now in 1 meter there are 100 centimeters, but we're doing centimeters squared, so we're going to need to square that. Going to give you an area of 3 times 10 to the power of negative 4 in meters squared. So let's substitute that in over here. We have 3 times 10 to the power of negative 4 meters squared, then multiplied by the cosine of the angle 6 degrees. And this gives you an answer of 6.0 Teslas. And that's it for this example.